In picking topics in meteorology that I want to cover this semester in this short kind of 3-week course on meteorology, I picked this topic of why are the skies blue? The skies are blue actually because of something called Rayleigh scattering, and it's a proper name, so Rayleigh scattering. And just to let's see, excuse me, how do I say this? Remember we talked about that electromagnetic radiation where we have gamma rays, and here we have radio waves, okay? And then here we have visible light. Remember that topic? This is electromagnetic radiation. And in visible light, actually, we have the Roy G. Biv, all colors of the rainbow. And each one of these is a different wavelength, Roy G. Biv. Okay, and since they are different wavelengths, they actually then respond or are scattered by the Earth's atmosphere differently. Specifically, if we look at the shortest wavelength, so this is short wavelength, oops, and this is long wavelength. If we look at the shortest wavelengths over here, the Biv, actually, the blue, indigo, violet, these are scattered by the Earth's atmosphere. The nitrogen and the oxygen in Earth's atmosphere. Scattered, you got the idea. So here we go. I think this is a pretty good little drawing down here. We have this guy right here, okay, and here we have Roy G. Biv coming from the sun, all colors of the rainbow coming in, and here we see the blue, indigo, violet that is scattered, okay. And this scattering actually creates this effect when the sun is up of giving us these blue skies. Is that not cool or what? I love it. Well, there's just a little bit more to the Rayleigh scattering, and it actually has to do with when the sun is low on the horizon, either at sunrise or sunset, why do the skies in that vicinity on the horizon have this pretty kind of red color to it? Okay. So what happens, and this is, I don't know if I can kind of convince you of this, is when the sun is low on the horizon, actually the amount of the Earth's atmosphere that the sun goes through is greater. Let's see if I can, if I go back to the previous slide. Okay, I know this is kind of highly irregular, but this actually, we have the sun over here, okay, and notice that the amount of atmosphere that the sun has to go through is this big, okay, because the sun is at what we call a very low angle. This is the angle of the sun. If we compare that to the sun being high, okay, having a great large angle with horizon, 90-degree angle with the horizon, then this is how much of the Earth's atmosphere it has to go through. Now, I guarantee you that this red is less than this purple down here. This is a lot more of the Earth's atmosphere for the light rays from the sun to come through. And so we have scatter, 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 basically scattered to the point of removing the blue, indigo, and violet. So what that then leaves is simply the kind of reds to come through. Okay, so notice here we have the kind of the reds coming through because the blue, indigo, and violet have been scattered. And it's kind of neat. I kind of think, I wish if I could go, I don't know, you could actually see that phenomenon if you are in a plane. I don't know how that would work, but so the skies get kind of pinkish here where the blue, indigo, violet is scattered. One of the things I think is neat is if you hold up or look at a sign, like if I have a sign here, and you have this morning light or the evening light from the sun when it's low on the horizon shining on the sign, you'll see it looks like kind of an orange flashlight. Okay, because the blue, indigo, violet has been scattered out. I don't know what to say about the green, okay, but then that leaves your red, orange, and yellow to make those pretty colors. And then growing up around here, around harvest time, sometimes those particles will actually, there'll be extra dust in the atmosphere, and actually those dust particles can give an extra little enhance the appearance of those long wavelengths as the sun is low on the horizon, giving us very colorful sunrises and sunsets.